Welcome back. So now we're going to be talking about composition of two functions. But before I define what a composition of functions are, let's do some examples. Or preliminary examples. So we're given f of x equals 2x minus 5 and g of x is equal to x squared plus 3. So for A, I want to find g of negative 1. So how do we find g of negative 1? So what is negative 1 saying? So g of x, this means that this is a function of x, so whatever is in here. So g of negative 1, it's x is equal to negative 1, right? So wherever I see an x, I'm going to plug in a negative 1. So this is negative 1 squared plus 3. So negative 1 squared is 1. So this is 4. The next one, we want to find g of t. So what does that mean? That means x is equal to t. So what does that mean? Wherever I see an x, I'm going to plug in t. So this becomes t squared plus 3. Right? So overall, so if I do like g of triangle, what is that? That is triangle squared plus 3. Wherever I saw an x, I plugged in a triangle because x is equal to the triangle. Right? So as you can see, like whatever we put in, like wherever that variable is, that's what we just plug in. Right? So then we haven't worked on f. So what is f of p? So f is also a function of x. And so wherever I see an x, I'm going to plug in p. So this becomes 2p minus 5. Right? So now let's do more examples. So we have two more. So E, we want to find g of 2. So what does this mean? This means x is equal to 2. So wherever I see an x, I'm going to plug in 2. So this becomes 2 squared plus 3. So 2 squared is equal to 4. So it's 4 plus 3, which is equal to 7. Right? And then the last of our preliminary examples, we want to find f of 7. So wherever I see an x, I'm going to plug in 7. So I have 2 times 7 minus 5. This is 14 minus 5, which is equal to 9. And guess what, guys? With these last two examples, we just did a composition of functions. Right? So what is a composition of functions? So let's look over to the right, and it says the composition of f and g denoted by f of g. So f, like little circle g, is defined by the rule f of g of x is equal to f of g of x, that provided that g of x is in the domain of f. Right? So one thing before we start on any examples, f of g, okay, maybe I should make it a little better. So f of g, this is not equal, no way, no how, is f times g. Okay? So if there's clearly an open circle, okay, and even you'll have to do it on your own work, you have to make it very clear that you are taking a composition. So maybe, in this case, so instead of maybe doing a dot, you can still do fg, okay, maybe f times g, right? It doesn't matter, but this is f of g, right? It's not this. I just want to emphasize that these are not the same, right? So how do we just do a composition of functions? So before we move on to our examples, what we essentially did is I asked, what is f of g of 2? Okay, so then this is, so by our definition of f of g of x, this becomes f of g of 2. We found g of 2, which was 7, so this became f of 7. Okay, as you can see what we did in the example, we got 9. Right? So composition of functions, it's really not that bad. All right, as long as the biggest thing about composition of functions is you have to you have to know this. If you know the definition, like what it means, like when you see f of g of x, how can you rewrite it? Then it's not as bad. Right? So that's just the biggest thing. You need to know the definition. All right? So now that we've already done an example without even knowing it, let's do an example. Right, so let's go to this one. Okay, so we're given three functions. We're given f of x, which is equal to x minus 5, g of x, which is equal to x squared, and h of x equal to the square root of x plus 2. And we have four parts in this, right? So we have, so for A, we want to find f of g of 4, right? So we have, so how do I write f of g of 4? This is f of g of 4. Okay, so looking over here, we need to find what g of 4 is. So we just plug in, so we get g, and wherever we see an x, we're going to plug in a 4. So this becomes 4 squared, okay, which is f of 16. Right, and then now we want to find f of 16. So wherever I'm going to take this f of x, and wherever I see an x, I'm going to plug in 16. So this becomes 16 minus 5, which is equal to 11. So f of g of 4 is equal to 11. If you're not, over here it's just more customary to keep it in the parentheses, but if you'd like, you can also like make, like, say, side note. Let me show you. So if I add some space here, yeah, I think that's enough space. Just put like side note, g of 4. Then you can say, so you know, g of x is equal to x squared. So this is 4 squared, which is 16. Then that would take away this, and you could have gone straight to here. Right, but you have to specify that you're finding g of 4, and you cannot say this cannot be equals g of 4, right? Because they're not the same thing. Right? So, but I think it's just better, to be honest, in my opinion, I think it's better to just keep it in the parentheses, right? Because I even think that this is a lot more writing than what has to be. Alrighty, so now we found f of g of 4. Now let's find g of f of 4. Okay, what is g of f of 4? By looking at our definition, this is g of f of 4. Okay, so now we are going to, so wherever I see a 4, I'm going to plug it into the x of my f function. Right? So what is that? So f of 4, this is going to be 4 minus 5. Okay, what is 4 minus 5? That is negative 1. And now wherever I see a negative 1, I'm going to plug it into my g function. So, what is it again? X squared? So it's going to be negative 1 quantity squared, which is 1. Right. So, maybe I made that green. Right. So what is the biggest takeaway from A and B? Notice, so we have f of g of 4 is equal to 11, g of f of 4 is equal to 1. So that means that f of, like, the composition of functions, they are not commutative, right? So I can't just interchange. So if I was asked, give me f of g, I don't know, of 3, okay, you cannot do g of f of 3. Right? This is a big, like, you can't do it. So, but actually tomorrow, I think it's tomorrow, we will talk about, because there will be cases when f of g and g of f do equal, but those are special cases, and we'll get more into it tomorrow. All right? So, but just as a good rule of thumb, composition of functions are not commutative. You cannot just, they're not like multiplication or addition. All right, so now I'm going to copy this again. If I draw it straight. So what are we going to do now? We're going to do C and D. So for C, so for A, B, and the preliminary example E and F, we've just been evaluating composition of functions. Now we're just going to find general compositions. So we have h of f of x. So what is that? This is h of f of x. Okay, so what am I going to do? I'm just going to stick f of x right in here. So this is x minus 5. So for this h, wherever I see an x, I'm going to replace this with x minus 5. So, okay. Right, so wherever I saw this x, I plugged in this x minus 5, which is why I put parentheses. Okay. So now we just evaluate. So x. So these parentheses, there's a 1 coefficient in front of it, so it's just x minus 5. And then so this becomes x minus 3. And this is h of f of x. Right? And now D, so our last example for the day, we want to find g of h of t. Okay? So what is g of h of t? This is g of h of t. Okay? So usually when we say it kind of just means there's going to be like a parentheses around it. So that's why when I do it, I'm just thinking g of, so parentheses, h of t. And then you have to finish, whatever you open, you have to close. So then we just close the parentheses. So that's how I just kind of remember just g of h of t. Okay. So, and then I think of, because like this little circle, so it's like, of, so it's like the first part of the first half of, right? So whatever helps you just remember what a composition is. That's how I remember it, and it's worked for me for years. So let's go back to our example. We have g of h of t. So what does that mean? So I'm going to take this h, right? But I have a t. So wherever I see an x, I'm going to plug in t. So this is square root of t plus 2. Right? So now g of the square root of t plus 2. So wherever I see an x, I'm going to put in the square root of t plus 2. So what do I mean? This is going to be square root of t plus 2. So when I solve for this, so recalling back from chapter 7, so when we have the square root to the square, so the square root has an index of 2, and then this power is 2. So what does that mean? They cancel. So what am I talking about? I'm talking about this. Okay, so what does this equal? This equals t plus 2. Right? So that is g of h of t, which is equal to t plus 2. So that is all of our examples today. So if you guys have any questions, please let me know. Yeah, so we're on what? We have just 2.5 weeks left of school. So you guys are doing great, right? Just keep it up. Just a couple more weeks, and then we get our summer. You guys have a nice day. Bye.